Every planet and moon in its path will be incinerated. The only thing left of our sun will be a splash of color, visible from thousands of light years away, like this.
So the human race has its warning. We have 5 billion years to clear out of town.
But even the death of our own sun hardly compares to a more powerful downfall. Some stars are over 100 times more massive than our sun. The bigger the star, the shorter its life, and the more violent its death. These stars explode in a massive fireball called a supernova.
Not every kind of star can explode as a supernova. The sun can't, for example. It just lacks the oomph. It doesn't have the mass that you need to be able to get what happens in the core to make a star blow up. There are a handful of stars in the galaxy that are definitely capable of doing this.
Every star is carefully balanced between the inward pull of its gravity and the outward pressure of the heat it generates from nuclear fusion. When it runs out of fuel, the pressure needed for balance is gone. Gravity now reigns supreme. The star caves in and explodes. The full fury of a supernova destroys the star and everything around it. One such giant star has already exploded in our own galaxy. Hubble Space Telescope recorded the aftermath.
The Crab Nebula is the expanding wreckage from a supernova that occurred in the year 1054. The explosion of the supernova was recorded by Chinese astronomers, so we know exactly when the explosion was.
The expanding debris from this 1,000-year-old supernova is still moving into space at over 3 million miles per hour. But the image is more than just a snapshot of ancient history. For scientists, the interconnected web-like filaments offer a clue as to the nature of life itself. The basic elements needed to create life are formed in the heart of stars. When stars explode, these fundamental elements are scattered throughout the universe, seeding distant nebula clouds, which give birth to new planets and new life.
The hemoglobin in your blood, when you bleed and it's red, that red color is due to oxygen, and it's due to iron that is in your blood that was created in a supernova. The gold on your wedding ring is created in a supernova. Calcium in your bones was created in a supernova. And so we learn so much about the universe itself when these stars die.
Hubble is giving scientists the ultimate learning experience by monitoring one particular star, Eta Carina, back in the Carina Nebula.
This is a star that is a bit of a mystery. It appears to have about 100 times the mass of the sun, and that is the upper limit. The more massive a star is, the hotter it is, and the surface of the star is so hot that it can't even hold on to its own gas. It's constantly blowing off a stream of gas.
For over a decade, Hubble creates a series of photos of Eta Carina. The photos show two enormous lobes of superheated gas erupting from the surface. Although Eta Carina is a young star, its huge mass makes it unstable. This star will not survive for long.
This is one of the very few stars that we can point at and say, yeah, that one's going to go.
When Eta Carina goes, it will become one of the most devastating supernovae ever recorded.
When the light from the explosion reaches us, it will be an extraordinary sight. It will be almost as bright as the full moon. All that light concentrated into a point of light in our sky. It will cast shadows at night.
The fireworks will begin when the star runs out of fuel. The gigantic star will destroy itself in just a few seconds. The core of the exploding star will bear the full brunt of the catastrophe. When that happens, it will leave behind the one outer space phenomenon that has long captured the imagination of stargazers: a black hole. The mysterious black hole is the product of the violent and powerful explosion of a supernova, at least in theory. Before Hubble, there was no conclusive proof that black holes existed at all. The modern concept of a black hole comes from Einstein's theory of general relativity.
If you take matter and you make it massive enough, dense enough, the gravity will be so strong that you will create a region of space that light can't get out of. It truly does make a hole in space. You can get into it, you can't get out of it. It's sort of like a cosmic lobster trap.
According to Einstein, a black hole begins with a very large star. It must be at least 4 times bigger than our sun.
A black hole is a simple thing. It is a hunk of matter which somehow has gotten so small that the gravitational field right around it is so strong that light cannot escape from it. So even if it tried to emit radiation, the photons would fall back. They would be sucked back by the gravity of the black hole, and it would look invisible.
During the blast of a supernova, the inner core of a star collapses into a single point, smaller than a pinhead. Astronomers call this single point a singularity. A singularity is an object with no length, width, or height, yet it retains most of the gravity of the original star. One of the primary goals for Hubble is to prove once and for all whether or not black holes exist. But how do astronomers search for an invisible point? They decide to focus Hubble on the centers of galaxies. What they find are stars zooming around at very high speeds. This is not how stars normally behave. Most stars move along at relatively slow speeds. But down in the central hub of galaxies, stars are being thrown around by the gravity of something massive, yet ultra-compact. There can be only one cause for this effect: the fabled black hole. Further evidence of black holes comes from Hubble's images of a mysterious jet some 5,000 light-years long. The jet is piercing the heart of a giant elliptical galaxy called M87. The jet in the galaxy M87 is caused by enormous amounts of gas and dust piling onto the black hole. There's so much material that a traffic jam occurs. The gas and dust back up, forming a disk. Some of this material escapes and creates the jet. The black hole is showing itself with a parade of light. The connection between a galaxy and the black hole at its heart is not yet well understood. But astronomers recognize that black holes play a part in the formation of galaxies.
As far as we know, every big galaxy has a black hole at its very center. We don't know exactly how this happens. It must have something to do with gas falling in as the galaxy evolves.
And this has been one of the revelations come through a space telescope, is the real deep and fundamental connection between black holes and galaxies done by looking at M87, but also, dozens of other galaxies.
Before Hubble, black holes were merely a concept, an unproven part of astronomical lore. Hubble Space Telescope has changed that forever. The violent forces that create stars far off in space also shape our own solar system. In the summer of 1992, Comet Shoemaker-Levy 9, or SL9, passes too close to Jupiter. The mile-long comet is trapped by the planet's gravity. SL9 breaks apart. The fragments spread into a long single line, which Hubble showed in an image called the String of Pearls. Data suggests that these pearls would soon collide with Jupiter. So planetary astronomer Heidi Hammel submits a proposal to NASA.
We had known for many, many decades that collisions are an incredibly important part of solar system evolution. You look at the moon and you see craters. So you know that collisions are important. Even on the Earth, we've known for decades that collisions have played a big role. But we never have had an opportunity to see a collision.
In July 1994, the team gathers at the Space Telescope Science Institute in Baltimore to watch the comet make contact with the planet.
We didn't know what was going to happen when Shoemaker-Levy 9 hit Jupiter. And it was really possible that nothing would happen at all.
The first image of Shoemaker-Levy 9 comes in. It shows no signs of impact. But then, new images come in.
So there's a red spot, so you know. Atlas
Oh,
yeah, that's it.
my God.
That's it.
Look at that. Look at The planet had rotated enough that the impact site was visible on the disk, and it was huge.
The team is watching the comet hit the planet in real time. This is cosmic history in action. The press is standing by in an auditorium above.
And at the same time, on the screen of the press conference, Gene Shoemaker was saying,
if we should see these things at all.
And we were downstairs going, woo, look at this, amazing. And we go, we have to show this. You can't let him sit up there saying we don't know. We know.
And I think we may have some up-to-date information from Heidi Hammel.
I have a raw laser printer output. This is as raw as it gets. We can actually see the impact site itself.
For an entire week, Hubble captures images of Shoemaker-Levy 9 as it mercilessly hammers Jupiter.
We calculated the heights of these explosive plumes out of Jupiter to rising something like 3,000 kilometers out of Jupiter's atmosphere. It's huge. It's planetary-wide scale. What there was left was clouds that had been seriously disturbed over thousands and thousands of miles, seriously disturbed up to temperatures of tens of thousands of degrees.
Hubble's pictures of the comet impact prove that the violence that formed our planet billions of years ago continues through this day.